Am I audible? Hello.
Yes, ma'am.
Okay. Let me also know that you can see the presentation. Can you see the presentation?
Yes, ma'am.
Yes.
So the surface water, the water from river can be treated through like following process which is shown here. First, we have to screen the water. That means the big logs of wood and other uh, stones etc. should be removed from water using a screen. Screen is nothing but a kind of bars assembled together with like at certain distance, say 10 millimeter, 10 millimeter and so it's a huge kind of you can say frame the where iron bars are stacked. So water passes through it. However, big wooden logs and stones, they remain on the other side of the bar. After that, the we need to maintain the pH of the water in order to make coagulation, effective coagulation, you can say. uh, for that, the lime is added and rapidly mixed. So it's a if the pH is fine, means pH of the water is in a particular range where coagulation can be done effectively, then a direct coagulation can be done, and then for flocculation. I will explain you what is coagulation and flocculation. So this is kind of chemical process where which is applied to water in order to remove the colloidal particles. In coagulation, the aim is to remove the colloidal particles, to make the colloidal particles big enough so that they can be settled down in sedimentation basin. So after that, sedimentation basin is actually nothing but a tank where the water is stored for certain time period, and all the impurities which is suspended solid and inert material, as well as coagulated flocks can be settled down on the bottom of the tank, which can be removed from the tank, from the bottom of the tank, and the clean water can be passed to the next treatment unit, which is the rapid sand filter. There are two type of filters: slow sand filter and rapid sand filter. However, rapid sand filters are more common because the pressure drop in these filters are low. Uh, in filters, like there are different layers of gravel and sands are used to to percolate the water through these layers, and the small particles for flocks, colloidal particles, which are like coagulated and have made big flocks, can be removed. Even sometimes to some extent the bacteria is also removed, and then the clean water from the bottom is passes to another unit which is called as like for disinfection. In disinfection, the chlorine, ozone, various disinfectant can be used to kill the bacteria, and after that the water can be supplied, either storing in the reservoirs or directly through water distribution pipe. So this is the overall treatment process. We will learn about the coagulation in this class. I'm sorry, I'm not well, so last time all therefore I did not take class on Wednesday. Okay, so coagulation is defined as the addition of chemical to a colloidal dispersion which results in particle destabilization by reduction in force. So what happens, like The colloidal particles are basically negative in charge, and in order to neutralize this negative charge, we add some kind of chemicals. The most common chemical is alum. So alum is dissociated into Al plus 3 and SO4 uh, ions. Al plus 3, which has three positive ion, positive charge on Al, that is effective in neutralizing the colloidal particle and therefore reducing the force, the repulsive force between the colloidal particle. So it brings the colloidal particles together and ultimately results in coagulation of the neutralized colloidal particle, and making it big flock to get settled down. However, there might be different mechanisms working together in this process. Some like four mechanisms are explained here. Ionic compression, that means there are like too many charges of A plus Al 3 plus is available, means aluminum um, eh, ions are available. Therefore it will cause the compression of the whole layer. So here it is written, a high ion concentration compress the layer composed predominantly of positive charge, which is positive charge on aluminium, or maybe copperous, which is ferric sulfate, is also used as a coagulant. So any positive charge ions, their presence, their presence in high amount, cause the compression on on the colloidal particle, and then towards the surface of the colloidal particle. And if the layer is sufficient compressed, the attractive force will be predominant. So what will happen? uh, the positive charge which is present in large amount cause the compression towards the surface of the colloidal particle, and until the attraction force between colloidal particle and positive ions will be dominated, and therefore it will neutralize the colloidal particle. This is what a kind of theory we can expect, like this may be happening in the coagulation process. Then adsorption and charge neutralization, maybe this alum particle or any kind of positive ions, they are adsorbed on the surface of the colloidal particle. This is another theory or another possibility of having the attractive force between colloidal particle and aluminium ion, or you can say positive charge coagulant, and that may cause the neutralization of charge on colloidal particle. Is that clear? Adsorption is the process which is the physical process, right? It's not a chemical, it's just attachment of ion on the surface of the colloidal particle. Is that clear? Anyone?
Ma'am, what are the type of colloidal particles?
No, there is no type. It's like colloidal particles are generally very fine clay particle which will have negative charges. This is what we um, get from any experiment, that these particles are basically mainly negative charge particle. They are very fine clay particles.
So, ma'am, there is not any chemical formula.
No, 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 no. There is no chemical formula for colloidal particles. See, three type of particle you can expect. One is inert material. Inert material means, for example, bone, very small bone particles, or eggshell, or means this, generally this you will learn in wastewater. But this kind of thing you will have, which is like inert, uh, slightly larger particles, you can say. Then you will have the Discrete particle means the fine particles. They are not like in nanometer size, they are in micrometer or millimeter size, but they are discrete. That means they are independent, they do not have any kind of force. Okay. And this discrete particle can be settled down. That is also, we know, the suspended particles, so that they can be settled down while providing enough residence time in a sedimentation time. The third type is very fine, maybe nano sized particle, which are the colloidal particle, and they have Brownian motion. They cannot set because they do not have enough mass, they don't settle down easily. So those particles are uh, very fine clay particles. They do not have any chemical formula, but they are supposed to have negative charge. This is what is established through experiments. However, nobody knows like what kind of particle they are. Probably organic kind of, they have organic kind of structure or something, but it's not it's not written anywhere. So these colloidal particles are very small in size, having Brownian motion. They do not settle down easily, so we have to increase their size. In order to increase their size, we have to have some charges to neutralize this particle so they can come together and make a flock. This is what is behind the coagulation theory. Okay, is that clear now?
Yes, ma'am. So, ma'am, basically, the cation is adsorbing on the surface, and by which the charge is neutralized and they are coagulate. But there
Yes.
is no chemical reaction between the cation that we put in the water to coagulate
So
with the particle, no?
yeah, so this no, there is no chemical reaction between the colloidal particle and coagulant. Okay. uh, Adsorption is just physical phenomena on the surface of the colloidal particle. Al plus 3 ions get adsorbed, or Fe plus 3 ion get adsorbed, and they neutralize the charge of colloidal particle, because there are, say generally it says like single charge on single negative charge on colloidal particle, and 3 plus 3 charge on aluminum Al3 plus, right? So that is why it is more effective. Like Fe3 plus is very effective. So they have three times more charge, Al or Fe, than colloidal particles. So therefore they get easily, they neutralize the colloidal particle. This is what is a understanding is. Okay. So there is no chemical reaction, right?
Okay, ma'am.
Now there is another mechanism which is known as sweep coagulation. Sweep coagulation is basically when aluminium means alum, which is aluminium sulfate, is dissolved in water. It will form aluminium hydroxide by reacting with water, right? Its reaction with water will give aluminium hydroxide, which is a shapeless and gelatinous material. It doesn't have like you can say regular shape. So it's a amorphous and gelatinous sticky precipitate. Because of its sticky and sticky precipitate, it will provide a kind of, you can say, trap for the colloidal particle. Okay, so the colloidal particle will trap in this precipitate, and this precipitate is heavy enough, so it will come down and it will settle at the bottom of the tank. This is another mechanism probably happening in the coagulation process. Then interparticle bridging. The large molecule may be formed when Al or ferric sulfate dissociate in water. Hence, several colloids may become attached to one molecule, or various molecule may get in. So it's a opposite. It's saying that large molecule may be formed when Al or ferric sulfate dissociate in water. Okay, and then colloidal particle will go and get attached to the molecule. So it's just you can say opposite to what we have. seen here in adsorption or ionic compression. Okay, in ionic compression, we believe that the positive ion compresses on the colloidal particle because they are numerous in number. So they compress the colloidal particle and therefore they neutralize the colloidal particle. Here, the interparticle bridging, the large molecule may form when Al or ferric sulfate dissociate in water. Hence, several colloids may become attached to one molecule, or various molecule may get enmeshed, resulting in settleable mass. Okay, so it's a kind of opposite process. You can remember in this way. So common coagulant is aluminium sulfate, also known as alum, and this is the possible reaction which happen in the water when alum is added. There is a bicarbonate present. Calcium bicarbonate is present in water. Calcium bicarbonate reacts with alum and it can form calcium sulfate and aluminium hydroxide and CO2. So it is not the reaction with colloidal particle. It is a reaction with soluble calcium bicarbonate. Calcium bicarbonate is soluble chemical. Okay, it's not insoluble. It's not colloidal particle. So don't don't get confused with that. So aluminium hydroxide, which is formed as a flock, will cause the entrapment um, of colloidal particles. Okay, for the above equation, it can also be seen that the alum reacts with bicarbonate alkalinity. Okay, so this is what. Then, in addition of alum in water, cause permanent hardness in the form of CaSO4. Okay, now CaSO4 is a permanent hardness. It impart the permanent hardness which cannot be removed by just simply boiling the water. Okay, uh, there are temporary hardness which can be removed by boiling the water. The CO2 causes the corrosiveness. Okay, so CO2 is corrosive. Dose of alum can be determined in laboratory and may vary from 5 to 85 mg per liter. So mg per liter for relatively clean and highly turbid water. Okay, so this is the dose which can be given to water depending upon what is the turbidity of water or how much colloidal particles are present. The average dose is approximately 17 mg per liter. The coagulation work in alkaline water. If the water is not sufficiently alkaline, we need to add lime or soda ash. Okay, in order to make the water alkaline, we need to add lime or soda ash because there is a certain pH range in which only the alum works, and this pH range is between 6.5 to 8.5. Now, what will happen with permanent hardness and CO2? So we have to remove the permanent hardness and CO2. Okay, and that we will see in later slides. 1 minute, I'm getting one call. I don't know, it's important maybe. Uh, okay, let it be. So another common coagulant is copperas, which is copperas means it's a ferric sulfate. Okay, and this is the reaction which happens again. The permanent hardness will increase, calcium sulfate will form, and ferric hydroxide will form. Ferric hydroxide is again a gelatinous material which will capture the colloidal particle and it will remove the particle from the tank from the water in sedimentation tank. 1 mole of copperas will form 1 mole of ferric hydroxide precipitate. Copperas is used for water which is not colored and it works in pH range of 8.5 and above. So it work on more alkaline water, higher in range, like alkalinity is higher in range 8.5 and above. The quantity used is same as the alum, 10 to 30 mg per liter. Chlorinated copper is another type of coagulant. and reaction is given here. Again, it will form the ferric sulfate and FeCl3 and H2O. Effective coagulant for removing color, especially when the raw water has low pH. Okay, when raw water it's like acidic water. Ferric sulfate is effective in the range of 4 to 7 and above 9 also. Ferric chloride is effective in the range of 3.5 to 6.5 and above 8.5. Okay, the bottom line is there are various coagulant, and use of those coagulant depend upon the characteristics of the water. What kind of water is that? If it's a colored water, then you have to use different coagulant. If it's non-colored water, and what is the pH of water? The pH should be maintained in order to effective effective application of coagulant. Okay. Another coagulant
Ma'am,
is, yes.
ma'am, in the previous slide,
Hmm.
as calcium hydroxide is a good base, so why is it present in this form in the water?
Calcium hydroxide where?
In the reaction of part A,
Uh-huh.
we have calcium hydroxide, but is it present in this form? Because in water it should dissociate.
Is it present in this form? Means are you saying that this calcium hydroxide, right?
Yes, ma'am.
So yes, calcium hydroxide, lime. We generally add the lime. Okay. We in water it's a carbonate and bicarbonate are present in water, but lime is added in water. Is that clear? This is what you are asking.
Uh, Ma'am, I was asking how it is present in this form because it is a strong base, so it should dissociate.
No, it is not present in water. The lime is added in water and it will dissociate, but if ferric sulfate is available, it will react with ferric sulfate. Means if you put the ferric sulfate as a coagulant, and then you have to add the lime, and it will react with lime and it will form FeOH3. So lime, which is CaOH2, is not present naturally in water.
Okay, so ma'am, how basically we are removing the coagulant particles?
Okay, so FeOH3 is precipitate. Okay, which is again a sticky precipitate, to capture or you can say entrap the colloidal particle. So here the sweep coagulation, we have learned about the sweep coagulation, no? That mechanism will work. Okay, in both the cases, see there are different mechanisms. Okay, FeOH3, in case of FeOH3, only um, the one possibility is that sweep coagulation may work,
Okay, ma'am.
right? So this is another coagulant, and reactions are given. I am not going through the reaction. The This coagulant is costlier than other one, 1.5 times costlier than the alum, and very useful for water which does not have required alkalinity. Okay, if alkalinity is not present, then this can be used. pH range 6 to 8.5 is suitable for this coagulant. This is basically used for boiler, the water which is fed in boiler, and low hardness value. If the hardness is low, okay, with low hardness value. So the water we use in boiler, it should have very low hardness. Otherwise, the hardness will cause the deposition of the calcium carbonate, etc., inside the boiler, right? So that is why this coagulant is used to remove the hardness, to remove the collides from the particle, as well as uh, uh, for for the for the water which is fed in boiler. So it is good for that application. It is costlier, so we don't use it normally for drinking water purpose. Okay, it is not you can say economical for large quantity of water, to treat a large quantity of water for municipal water supply. Okay, so here the comparison between iron salt and aluminum salt are given. Most of the things I have told you. Iron salt, it produce heavy flocks, right? Iron hydroxide is heavier than aluminum hydroxide, and therefore it produce heavy flocks. The time required for the flock formation is smaller in case of iron salt. The work on large, it can work on large pH. Okay, iron bacteria imparts corrosiveness. There is a bacteria which can work in the presence of iron. Means they grow in the presence of iron compounds. They impart more corrosiveness than you can go to I don't know if it is given in the book, but I found it on internet. I don't know if it's given in the girls book, but you can found about the iron bacteria on internet. So it's a common type of bacteria which are actually, I just don't remember. I will see if I have written something here. No. Okay, I will add something about the iron bacteria here. So impart more corrosiveness than alum. Good oxidizing agent removes H2S and its corresponding taste and odor from water. Storing and handling of iron is a big problem. Okay, because it's a corrosive, so its storing is a big problem. More frequently used for treating the sewage. So this iron salts are more frequently used for treating the sewage than water. So this is the problem. This is very simple problem. It says that determine the quantity of alum required in order to treat 13 million liter of water per day at a treatment plant where 12 ppm of alum dose is required. Also determine the amount of the carbon dioxide gas produced per liter of water treated. So this is the reaction. We know one mole of alum produces 6 mole of CO2. The total quantity of alum required would be the product of total water treated, volume of water treated multiplied by the alum dose. So here the total quantity of alum required per day would be 13 into 10 raised to 6 into 12. Then molecular weight of alum 666 gram approximately. Molecular weight of CO2 is 44 gram. So that means 666 milligram of alum will liberate 6 into 42 milligram of CO2. Therefore, 12 milligram of alum will liberate this much of CO2. Therefore, total CO2 liberated from treatment of 13 into 10 raised to 6 liter per day of water would be this much. So it's very simple calculation. I think it's very clear also. So is there any question in this part? Okay, let's see. So this I have put some of the simple, you can say the question over here. You can try to solve it. It's there is nothing complicated in this, but just try to solve it. If you don't find like answer, then let me know. If you find any difficulty, then let me know. Okay, so okay. Flocculation. After coagulation, which is also known as very rapid mixing process, means in order to dissolve the coagulant, uh, we mix the coagulant in water at high RPM. So we used a mechanical device which is rotated and to mix the coagulant in the water, and the rotational speed is very high. Now, once the coagulant is dissolved, coagulant is not dissolved, you can say well mixed in water, then in order, and the flock formation starts, in order to bring these flocks together and make a large flock for settling, to settle the flock trapped with the, means the colloidal particle trapped inside the flock, we need to have very slow mixing of the whole mixture. Okay, so this slow mixing of the solution after adding the coagulant is known as flocculation process. It is basically slow mixing or agitation process in which destabilized colloidal particles are brought into contact in order to promote agglomeration. Okay, so in order to reduce any kind of you can say repulsion between the colloidal particles, once they are neutralized, we want them to come together and get coagulate and or agglomerate and make the big flocks. Okay, so that process is known as flocculation process. The rate of flocculation depends upon the turbidity of water, type of the coagulant, and its turbidity of water means like if it's a highly turbid water, means generally its speed is, it means what I can say. See, the whole flocculation process, the RPM of the mechanical device, it's a complex, you can say, calculation. I taught it in advanced wastewater treatment class. So you don't need to learn that. So I will explain like it's not like simple relation between turbidity and the flocculation process, but I will just add some more lines over here to clarify it. Type of coagulant and its dose, and temporal mean velocity gradient. So this temporal mean velocity gradient is calculated in flocculation, before flocculation process. All these are like you can say numerical can or formula are available to calculate this thing, but we are not going through that portion of flocculation in this class because it is related to advanced classes. Okay, it is out of scope of your uh, course. Let Okay, so I will add some more information in this slide. Let me start one more topic, which is very small topic, and that is related to, 1 minute, softening. So water softening is to remove the hardness. Okay, softening means to soften the water means remove the hardness. Okay, and this can be done by, like, various chemical can be used to soften the water. And alkalinity, we know, we have learned about alkalinity and hardness in previous class. Alkalinity is basically because of the carbonate, bicarbonate compounds present in water. There are minor source of alkalinity also, but majorly the carbonate and bicarbonate compounds impart alkalinity. Hardness is because of calcium and compounds of calcium and magnesium. um, they impart hardness to the water. And there could be means carbonate, as well as means carbonate compounds, as well as non-carbonate compound. Okay, so hardness could be both because of carbonate and non-carbonate compounds. Um this is an example of carbonate. I think we have seen the numerical on hardness, right? Did we see?
Yes, ma'am.
Okay, so I am not repeating it. The solution is also given, you can go through it. Okay. So alkalinity, carbonate, bicarbonate, OH minus OH and minus H plus ion. This we have already done. Temporary hardness is the hardness because of the carbonate bicarbonate, and that can be removed just by simple boiling the water. While permanent hardness is because of sulfate, chloride, etc., non-carbonate compounds. And in order to remove the permanent hardness, we need three different type of treatment can be done. Lime soda treatment, where we change process process preparation. Mute your mics. Okay, lime soda process. In lime soda process, we add the lime. We add the lime and soda. Lime is CaOH2 and soda is Na2CO3. Okay, these two can be added, and they react with carbonate, bicarbonate, and non-carbonate hardness, and convert them either to calcium carbonate, which is a precipitate, or magnesium hydroxide. Okay, these are the precipitable compounds. They precipitate and they can be removed in sedimentation tank. Okay, so this is what is written here. However, the complete calcium carbonate and magnesium hydroxide cannot be precipitated, cannot be removed. Some amount of these compound remains in water. In order to remove that, we have to do the recarbonation. Recarbonation means passing the CO2 through water. So again, this calcium carbonate and magnesium hydroxide change into soluble calcium bicarbonate, okay, or magnesium bicarbonate. So if some amount of calcium carbonate and magnesium hydroxide present after sedimentation, then we have to pass CO2 in order to convert this to calcium bicarbonate and magnesium bicarbonate, and those are soluble in water, and they will not precipitate in the pipelines, means water distribution network, so and cause any problem. So basically, we try to avoid the precipitation of calcium carbonate and magnesium hydroxide in water distribution pipe. So okay, so for recarbonation, the main purpose is to avoid this precipitation of calcium carbonate and magnesium hydroxide in water distribution network. This is what I'm trying to say. Now, lime soda process. Lime reacts with non-carbonate hardness of magnesium to convert. So I will just show you all the reaction which happens in lime soda process. So calcium bicarbonate, magnesium bicarbonate, they react with lime. They form calcium carbonate, which is a precipitate. The magnesium carbonate, magnesium chloride, magnesium sulfate, they also react with calcium hydroxide and they form MgOH2, magnesium hydroxide, which is also a precipitate and can be removed. Uh, Free CO2, if there is a free dissolved CO2, that is also converted to calcium carbonate. Calcium chloride and calcium sulfate, it reacts with soda ash and converted to calcium carbonate, and which is again precipitable. The precipitates can be removed in sedimentation tank. However, some very fine particles may remain suspended. These may cause trouble by getting deposited on filter media, resulting in enlargement of the sand grain. So, in filtration unit, they can cause trouble in filtration process. They can also be deposited they will also be deposited in the pipeline, and therefore recarbonation is done in order to make these precipitate soluble. Okay, so the reaction for recarbonation is given below. Okay, so this is very so I'm not teaching you the ion this ion exchange base exchange process, zeolite process and demineralization process. Only one process we are learning in this class. Okay, is there any question regarding this? Is there any question? No question? Okay, so let's stop here. Next time we will see sedimentation. We will learn about sedimentation, filtration and disinfection. Three I think, and water distribution. 4 topics are remaining in this. Okay, so probably next week I will try to cover 2 to 3 topics.
Ma'am?
Yes.
Ma'am, IIT Delhi has its own water treatment system also.
IIT Delhi, no. IIT Delhi takes water from DJB and some groundwater resources IIT Delhi has. So they supply from these two sources. IIT Delhi has wastewater treatment unit now.
So, ma'am, there which process we are using?
In what?
Wastewater treatment.
In wastewater treatment, I don't remember, but once we discuss that. So generally in wastewater treatment, it's a it will have the primary sedimentation, then what is that? Activated sludge process, and then secondary sedimentation, and I don't remember, but they have sites tertiary treatment also, but I have to confirm it. Long back we discussed that, and then after that I didn't have any idea, but basically activated sludge process, and they have RBC or rotating biological reactor, RBC also. I will find it out, and I will let you know what processes we are using in wastewater treatment over here. But we don't do water treatment. We get water from DJB, Delhi Jal Board.
Okay, ma'am.
Ma'am,
Yes,
please upload the first 2 presentations which you have covered of
I
water
will.
supply. Yeah, and ma'am, the attendance has still not been uploaded.
Actually, the problem is with attendance. Last 2 days, I couldn't contact my TA. I was not well. My kids were also not well. I thought like I will contact her, Ruksha, but I couldn't. Let me call her today, and I will ask her to upload the attendance. Okay? I know that is due from long, but I
Okay,
hope
okay.
to do it today. So if you want, you can learn about what water treatment processes DJB is using. It will be given on DJB. Does, I don't know DJB has site or not, but it will be available somewhere in water treatment plan in Delhi. I visited once the water trip when I joined here, but after that I think I did not visit that one. Uh, what I will do, I will put some of the facts related to water
Ma'am,
in Delhi. Huh?
Ma'am, we have air treatment plant in Ames and at many other places in Delhi. So
Hmm.
how they are working?
Again, repeat your question, please.
Air treatment plant.
What treatment plant?
Air, like for
Air treatment plant? What is that?
maybe something to reduce the pollutant concentration in air that
No,
are installed in some places in Delhi, like in Ames.
no. And there is no air treatment plant. Probably it's a smoke towers are now very uh, becoming famous. However, there is nobody knows how much this smoke tower can reduce the pollution. It's nothing but kind of a filtration uh, where like large filters are stacked or in housed in a in a chamber, and the water is the water the air is passed through that chamber, and the clean air goes out. So no air treatment. But I will give you an idea about water treatment units which are being used in DJB, used by DJB. That I have to find out. Yeah, it's a there is a site of DJB, delhijalboard.nic.in. So that site will have um, water quality report is also there. Yeah, no, I will put some of the fact related to water treatment in Delhi. Okay, next time. Is there any other question? Okay. Okay, so I'm leaving the meeting. Okay, thank you.